We're going to talk about subtracting mixed numbers. And before we begin, I just want to review the concept of fractions a little bit using these three strips. One strip, this blue strip, is actually made up of 4 pieces. So each one is 1/4 of the whole strip. It takes 4 of these 1/4 pieces to equal 1. So I could write that as 4 out of 4 pieces are needed to equal 1. I need, out of the green, let's see, each one is 3, so 3, 6, 9, 12. 12 of the 1/12 pieces also equal that same 1 length. And lastly, here, I've got 36 of these little cubes that still add up to just 1. So 36 of the 136 pieces would also equal 1. The point of this is to show you that I can take any number I want and divide it by itself, and I'll still equal that 1 whole. And so we're going to need that information both when we're multiplying to get a least common denominator and when we're borrowing to make a fraction larger. So let's take a look at the steps for subtracting mixed numbers. The first thing you're going to want to do is find the least common denominator for your fractions. And then the second step would be to compare them now that they have the same denominator. If the first fraction is larger than the second, for example, if you had 3/5 minus 2/5, well, 3 out of 5 pieces of pizza is going to fill you up better than 2 out of 5 pieces of pizza. We would just subtract. You would take any whole numbers you have and subtract those, and you would subtract your fractions. If you need to simplify it or reduce it, you can do that. And so that part's pretty straightforward. Where it gets a little trickier is if the first fraction, once you've got it with its least common denominator, is compared to the second and it's less than that. If it had been 2/5 minus 3/5, for example. We're going to need to do 2 more things. Both of these are going to happen to that first mixed number. We're going to subtract 1 from the whole number. Then we're going to add whatever that lowest common denominator is. In this case, it was 5. We'll add lowest common denominator over the lowest common denominator to the fraction. So example 5 over 5 would be an example. Or the other ones that we did before. We just did 4 over 4 and 12 over 12. And it helps if I finish writing one number before I start the next. There we go. Okay, so we are now armed with the steps for what to do. Let's do a quick look at the first one where everything works out easily. 5 2/3 minus 2 1/4. You might be able just to look at it and know that 2/3 is more than 1/4, but let's double check. Our lowest common denominator for 3 and 4 would be 12. Here's where we're allowed to multiply 2/3 to get an equivalent fraction by multiplying by 4 over 4. Why? Because 4 over 4 is still the same as multiplying by 1 in the long run. 1/4 can become 3/12 if I multiply the top and the bottom by 3. Just have to do the same thing to the top as you do to the bottom. Well, I can now say that 8/12 is larger than 3/12, so I can subtract. I'll take my whole numbers. The 5 minus 2 will equal 3. The 8/12 minus the 3/12 would equal 5/12. We've got to simplify that if necessary. 5 does not go evenly into 12, and 5 is a prime number, so I know it's simplified as much as possible. My final answer then would be 3 and 5/12, and we're done. Moving on to the next problem. Well, we get our next problem and it says 5 1/4 minus 2 1/2. You may already be able to tell that 1/4 is going to be less than 1/2. So we're going to need to change that first mixed number. Well, the LCD is 4, so 1/4 will stay 1/4, but 1/2 would have to be multiplied by 2 over 2 and become 2/4. Now our fractions can be subtracted, except 1/4 is less than 2/4. We've got to borrow. We're going to borrow from the whole number, so we'll have to subtract 1 from it. I can't borrow part of it. I have to take a solid 1. And I'm going to change the 1/4 into a bigger fraction. I'm going to add the least common denominator of 4 over 4 to that 1/4. And that'll equal 5/4. So in our original problem, 5 1/4 minus 2 1/2, we're going to think about 5 1/4 as being the same as 4 5/4. And 2 1/2 is the same as 2 2/4. We didn't have to borrow from the 2, just from the 5. Now 5/4 is greater than 2/4, so we just subtract. 4 minus 2 is 2. 5/4 minus 2/4 is 3/4. Is it simplified? 3 doesn't go evenly into 4, and 3 is a prime number. So our final answer can be 2 3/4. Let's do one more. 5 2/9 minus 2 3/4. To check and see if 2/9 is bigger or smaller than 3/4, we've got to do the least common denominator. For 9 and 4, that's going to be 36. We multiply 2/9 by 4 over 4 and get 8/36. And 3/4 by 9 over 9 to get 27/36. And I've already got my less than sign there because 8/36 is way less than 27/36. Give me this fraction of candy bar versus that one any day. All right, we're going to have to change our first mixed number. That 5 2/9, well, we've said that's equivalent to 5 8/36. We'll subtract 1 from the whole number. 5 minus 1 will be 4. And we'll add our least common denominator to both the top and the bottom of our fraction. We'll now have 4. 36 plus 8 is 44, and the denominator stays the same. Our original problem, 5 2/9 minus 2 3/4, we're going to think of 5 2/9 as 4 44/36. Our 2 3/4 will be thought of as 2 27/36, so that we can subtract the fractions. The whole numbers, 4 minus 2, 2. 44 minus 27 will be 17. We keep the same denominator, 36. 17 does not go into 36 evenly, and 17 is a prime number, so our final answer can be 2 17/36.